Okay, welcome back again, students. Now we will discuss about PPT 15, that is session 15. In PPT 15, session 15, we are going to explain demodulation of amplitude modulated wave. In the last previous session, we have discussed the generation of amplitude modulated wave, that is modulation of AM wave using emitter modulation. Now we will discuss the generation or demodulation. The demodulation is the process of separating the high carrier called radio frequency from low message signal frequency. Now this high carrier frequency is removed to the ground and low message signal is then fed to the loudspeaker to produce original replica of the sound. This is demodulation. The modulation always occurs at the transmitting station, whereas the demodulation is the reverse process of modulation. Here we are separating high carrier frequency from low carrier frequency. It is always obtained at receiving station. There are different types of demodulation of amplitude modulated wave. Now let us discuss about demodulation of amplitude modulated wave by a simple diode envelope detector. See, this is the circuit. This circuit contains a diode, and this demodulator circuit is called envelope diode detector. Here, this is the input transformer. Okay, between these 2 points, the input signal, that is the amplitude modulated wave, is applied. The amplitude modulated wave, that is AM wave, is our input. The input is amplitude modulated wave, and it is coupled into the secondary. Now this amplitude modulated wave is tuned to a carrier frequency FC, because carrier frequency should not be. Now when this amplitude, this is the signal which has both positive as well as negative. See, this is negative cycle, this is positive amplitude modulated wave. After passing through this diode has 2 junctions, P and N. When P is made positive, N is made negative, it is forward bias and current conducts. When P is made negative, N is made positive, it is reverse bias. Diode does not conduct and no current flows through this. Therefore, when this amplitude modulated wave is made to pass through this diode, this negative portion, during this negative portions, this becomes reverse bias and the current does not flows. During this positive portion, diode is forward bias and that current flows at the output. Therefore, this is the diode current. It has only positive cycle, whereas negative cycle is removed. Now this is our message signal, low frequency signal. This is our carrier signal. Therefore, now we need to separate this message signal from this carrier signal. So for that we have connected a capacitor here, and this capacitor is made ground. We know that the resistance power or reactance power offered by the capacitor is represented Xc, which is equal to omega C. 1 over omega is nothing but 2 pi f into C, where C is the value of capacitance is fixed, 2 pi is constant, C is constant. Therefore, the reactance offered by the capacitance is directly proportional to 1 by f. That means when the frequency is very high, very large, the ratio is very small. That means reactance offered by the capacitance is very small. Reactance offered by the capacitance means opposition for the flow of AC. This Xc is very small for high frequency. Therefore, Xc does not oppose for high frequency. It allows high frequency. Therefore, here you have both radio frequency as well as message frequency. This is our message frequency. This is our radio frequency. This radio frequency, high frequency, is bypassed through it is bypassed to the ground through this capacitor, and here you get a low signal frequency. This low signal frequency or current, after passing through this R, you get a voltage, that is our message signal voltage. Thus, amplitude modulated wave is converted into our message signal. This message signal is amplified, then applied to the loudspeaker to produce the original mechanical sound. This is our electrical signal. It is converted into mechanical original sound by loudspeaker. So this is the simplest form of diode envelope detector used to detect the amplitude modulated wave, that is used to separate the low frequency from high carrier frequency. Thank you.